Okay, this is the discussion of pointers in the C language. Let's start out by thinking about C programs running on our computer, and we think about the RAM that we have. So suppose you have in your machine 2 gigabytes of RAM. This orange box is a picture of the RAM in your machine, and each byte of those 2 billion bytes has an address. So there's a picture of byte 0, and there's a picture of byte 2 billion, thousands, millions, billions. And each byte in that whole 2 billion bytes has its own address. And this is called a flat address space. In RAM, you have all of your programs running, so the operating system is in there someplace, and you might be running Microsoft Word or some other applications. And here's your C program. When you run your C program, it gets loaded into RAM, and it executes in RAM. So, for example, your variables that you declare are there physically in RAM at some location between 0 and 2 billion. And we're going to use this concept of your variables, your data, being somewhere in RAM to help us understand talking about pointers. The address of the variable is where it exists in RAM. As the C programmer, you don't get to decide where your variables will be, but you can find out where they are. So here's a very simple declaration of an int variable a, and we're going to put 10 in it. Now, we can ask where is that piece of information stored by using the ampersand operator. So if you say ampersand a, we're going to read this as the address of a. The address of a variable is its physical location in RAM where that value is stored. So we would say that 10 is stored in RAM at this location, wherever a is, or the address of a. Addresses are just big integer numbers, and we usually would represent, when we look at an address, we would represent it in hexadecimal. So let's have a look at storing data in RAM. So here's the typical picture. A gets 10, and we have a box with 10 in it with the name A. And now we can say, well, the address of A is some big ugly number, and we write it as a hex number, so 3A5FD6, I just made that up, is where your variable might have landed in RAM. And now we're going to declare a variable that can be used to store that address. And we have a new data type here. We're going to pronounce this as int pointer. So int pointer PA, the variable PA is data type int pointer. And we use that to store an address. So the next line of code says PA gets the address of A. So PA is a variable. It's not an int. We're going to store an address in it. So address of A can go into PA. We're using the words address, pointer, and reference all in the same way. They're just addresses, physical addresses in RAM. So int pointer is our new data type here, and variables of this type can hold the address of an int. Not an int, the address of an int. Okay, now let's look at the dereference operator, also called an indirection operator. We have the same declarations that we had on the previous slide. We have int a gets 10 and int pointer PA, and we're assigning PA to be the address of A. And here's the new part in this slide. We're going to say asterisk PA gets 27. So I want you to read this one as what's pointed at by PA gets 27. Okay, where does the 27 go? Let's look over here. What's pointed at by PA gets 27. So the 27 goes in here at the address of A. What does the variable A have in it now? It has 27. So what we achieved was we changed the value in the variable A by using its address. Or we could say we changed the value in A indirectly, hence the indirection operator. You might guess that each data type in C has a corresponding pointer data type, that can hold the address of that type. So we have double pointer, car pointer, long pointer. Every data type that we have in C, we have another data type which is a pointer data type. Variables of that data type can store addresses of cars or addresses of doubles or addresses of long. And I should point out that up until now, it's not obvious to you why this entire concept would be useful. In this segment, I'm only aiming at having you understand the two concepts of the pointer data type and the address operator. Let's go into the development environment and have a look at using these new concepts. So I've created an empty project in C, and I'm going to do what we did in the slides. So I encourage you to launch your development environment, whether you're using 2005, 2008, or the newest one I'm hearing about is the 2010. It won't make any difference. This concept of pointers in C is from 1972. So any C environment that you have working will be fine. So there's our int a gets 10, and now we're going to declare a variable of this new data type, int pointer, and we'll say PA. Now let's make the assignment. PA gets the address of A. So an int pointer can hold the address of an int, and the ampersand is the address of operator. So let's print out some stuff just to make sure that we believe what's going on. A has, and also the address of A is, and I'm going to use %p here. %p is for outputting pointers, and the numbers will be represented in hex. So let's put ampersand A. Let's run this and make sure that everything is working so far. Okay, so here's what we've done. We have A has 10, and the address of A is this number, 12FF60. That's the number that we put in the variable PA. Now the indirection operator, and it's related to the declaration. Star PA gets 27. Where does the 27 go? So we're going to read that as go to the address. What's pointed at by the address in PA gets 27. Well, we know that PA is referring to the variable A, so 27 is going to go in A. And if we reprint A, we should then see that it's been changed indirectly to the value 27, and we do. That's good. When you're using indirection or pointers, I really encourage everyone to use the debugger. So I want you to set a breakpoint when you're trying to solve these problems and run to the breakpoint. Here's what we've executed so far. A has 10. The address of A is this number. Let's look at the variable PA, and there we can see that PA has in it 12FF60, which is the address of A. That's different from A, which has 10 in it. Have a look in the window that shows you what's going on. So what happened on that line there? We put 27 into that address. What's pointed at by PA is 27, and that's what's in the variable A now. So here's a summary of what we've accomplished in this segment. The pointer in C is nothing but the address of a particular byte in RAM. So pointer, address, reference, these are the same thing. The ampersand is the address of operator. So we can ask the program at runtime, what is the address of our variables? We have a new data type, a pointer data type, for example, int pointer, double pointer, car pointer. All of these are data types that can hold addresses. The asterisk, when it's not used in a declaration as a data type, is the dereference operator, or the indirection operator. When you dereference a pointer, that means that you go to that piece of memory and you use that piece of memory in the expression. So when we wrote in the example star PA, we're talking about what's pointed at by the address in PA. I'm hoping that you'll think that pointers are really not that difficult. They're just small integer numbers. Even if you don't understand now why we would want to use these, we're going to cover that in the next segment. I hope you're finding that pointers are not too difficult now. They're only integer numbers. They represent something that you can understand and address in your memory space, and we're going to understand in the following segments what these would actually be used for.